got knocked out.
Okay, ready? Okay. You need to find, so we talked about this a little bit yesterday at the end of class. For the tangent line, to know if it's over or under, you have to check concavity. So let's review the notation. You would put d squared y dx squared, then the line, and then the point that you are plugging in, which is 2, -1. Now, when I plug in, I'm going to use this equation. This is y. I already found dy dx. So look back in your part D. What was dy dx that I already found? What was dy dx? -12. So when I plug in, it's going to be 6y, which is -1, minus 6x, which is a 2. And then when I get to dy dx here, I'm going to plug in -12. Okay, then on the bottom, I want y squared, which is -1 squared. Okay, now, overall, looking at the signs, when I multiply here, 6 times -1 is -6. But -6 times -12, that second term is going to be what? A plus. 6 times 2 is 12, times another 12. 12 times 12 is... And then on the bottom, I have a -1, but it's squared, so that's going to turn to a +1. Now remember, I don't care necessarily about the number. I just care about whether its value is positive or negative. So if I have -6 plus 144, how's that going to turn out? It would be positive. Okay, what does that tell us about our graph? Is it concave up or concave down? Concave up. Very good. So I would say then y is concave up around to -1. So the tangent line will be, and then I'm going to draw a little picture to discover if it will be above or below. So concave up graph, where is the tangent line? Where's the tangent line compared to the graph that's concave up? It's going to fall below. Will be below actual value. Okay? Okay, and then before I go on, let me just say one more thing. If you signed up for the AP test, you have to try. If you're not going to try, then don't take the AP test. Okay, if you're going to give 0 effort in class, I'm not your mom, and I'm not your babysitter. But I'm not going to, oh, don't you want to try? No, just don't take the AP test if you're not going to try. Okay? Great. Can I turn the page? Okay, that's mean, Miss Joyner. If you take it and just get a 1, it makes me look like a dodo. So if you're not going to try, then just don't take it. Okay, it's optional. You don't have to take it. Okay, but if you are going to take it, then you should want to pass it. At least on some level of your soul, you should care about it. Okay, so look at number 7. Okay, your examples today are more like the examples that are on your homework, because your homework has several that involve chain rule, rewriting stuff. So when you're doing number 7, I'm going to jump to part C here real quick. It says to solve the differential. Is this right now separated into x stuff times y stuff? No, but can we fix it? Yes. What do both of those terms have? They both have a y. So when I rewrite for part C, I'm going to write it like this. dy dx equals y times, and then I'm going to separate the y out of the x stuff so that they're not right next to each other. Okay? So from my y term here, that's going to leave me with a 1. From my 2xy, that's going to leave me with a 2x. Okay, ready? We're going to separate. So where's my y going to end up if it used to be on the top? It'll be 1 over y. And then where does my dx go? up there, right? That's what we covered yesterday. So I'm going to have 1 over y dy, and then I'm going to have 1 plus 2x dx. After I separate, what's my next step? What do I do after that? Integral, very good. What's the integral of 1 over y? Natural log, absolute value y. And then on the other side, I have 1 plus 2x. What's the antiderivative of 1 plus 2x? Okay, 1x plus 2x, or x squared, and then when you divide by 2, the 2 goes away. Then plus c. Now, we want to get y all the way by itself, so if there's an ln with the y inside, we need to do what? E and e. Okay? These guys cross out. So now I have the absolute value of y equals e to the x plus x squared plus c. Okay, to get rid of the absolute value bars, you can drop them, but you have to put a plus or minus on the other side. So to get rid of the absolute value bars, I'm going to put this, plus or minus, and then all the exact same stuff. Okay? From here, I'm going to take my ordered pair, and I'm going to find the value of c that will make those two things equal. So if you look right here, it says that f of 1 is e to the 5. So this is my general solution. So e to the 5 should be the answer when I plug in 1. Okay, well, first thing I have to pick the plus or the minus. Which one am I going to pick here? The plus, because what's e to the 5? It's positive, right? So I want to pick what matches. So it'll be e to the 5 equals e to the, what's 1 plus 1? E to the 2 plus c. And then from here, how do I cancel out the base e's off both sides? Natural log. Okay, but even without doing that, what does c have to be if it has to add to 5 in the exponent? C has to be 3. Okay, so if you wanted to do it algebraically, you'd ln both sides. Okay, but we can just see that it has to be 3. So then what's my final solution? It'd be y equals positive e to the x plus x squared plus 3. Yes?
So in that first equation, like on top of the first bubble that you have, can you just put a plus sign and then scratch the c and make that a 3? And then we should be g or no?
If you crossed out the minus sign, which is I think what you meant to say, then yes. You would have to eliminate the minus sign and then plug the 3. That's fine. That's totally fine. Okay? Then come back up to part A. Do you remember how to do that? What's a linear approximation? Tangent line. Very good. Do we want to go back over that, or do y'all think you got it? Go over it? Good? Okay. So I'm not going to do that one just because you should know how to do a tangent line, but the important components of it would be that when you find your slope, that you label it. How would you label it? We already have the point right here. How would you label your slope? dy dx, line, and then 3, negative 2. Okay, and then remember that sometimes when you're plugging the point in, you're using the x and the y, but it is possible for you to only be using one or the other. Okay, question?
Your final answer for C, do you have to put the plus?
No. As long as you don't have a plus or a minus, that's what you can't have. But if you didn't put anything, it's implied that it's positive. Good question. Okay, let's just go ahead and do it just in case, because I forget that some of y'all weren't in here first semester. So I'd have my y first. That'd be negative 2 plus 2x is a 3, y is a negative 2. So that's really negative 2, and then 2 times 3 is 6, times that's minus 12. Negative 2 minus 12 is negative 14. Okay, that's your slope. Hi. Okay, so let's write the equation of the tangent line. So I'm going to have my y value is a minus 2, so it'll be y plus 2 equals. Then negative 14 is my slope. Then x would be minus 3. And then remember, after you've written the equation, the tangent line, they're asking you to use it to estimate 3.2. So you would plug 3.2 in right there. What is 3.2 minus 3? 0.2. Let's say that you don't know what that is. You can leave it like that. That's fine. And then how do you get rid of the plus 2? Minus 2 and minus 2. Okay? So I'd say y equals negative 14 times 0.2 minus 2. For an FRQ, okay, free response question, that's perfect. Now, if it was multiple choice, you should be able to multiply those. Okay, 2 times 14 is 28. Then 0.2 times 14 is 28 with a decimal in the middle. So it'd be negative 2.8 minus 2, which is negative 4.8. Okay? So that level of working with decimals you should be pretty comfortable with. Okay? But if it was free response, you could leave it just like that, no problem. Okay, come down for me, please, to number 8, the next example. Okay, there is one like this on your homework. What do you notice about dy dx on number 8? Does it have both x's and y's? No. All the other ones, when I separate, I've had x stuff and y stuff. For this one, you are going to pretend like the negative 3 is your representative for x. So when I separate, I'm going to do this. I have dy dx, e to the 2y. I'm going to bring this across, and I'm going to leave the negative 3 on the x side. So instead of having an e to the 2y, I'm going to have a 1 over e to the 2y. Yeah? So 1 over e to the 2y. And then I'm going to take my dx from here and I'm going to move it up. Now, here's why I'm allowed to do that. When I integrate negative 3 with respect to x, what am I going to get on this side? It'll be a what? Negative 3x. Am I going to end up with an x over there? Yes. I don't have one right now, but I will have one after I do my antiderivative. So this would be a negative 3x plus c. Okay, now take a look at this side. This happens all over your homework. You are going to need to use u sub. Okay? So it's not e to the y, it's e to the 2y. That's u sub. Now there's one other thing I'm going to have to do. Since e to the 2y is on the bottom, what will I do to the exponent? Make it a negative 2y. So since it's on the bottom, I'm going to bring that term up, and I'm just going to switch the exponent to be negative. Okay? So I'm going to work my u sub down here. So my u is a negative 2y. That makes du dy, because remember, I have to match my same letter. My du dy is just going to be a negative 2. Then I'm going to move my dy up, and I'm going to move my negative 2 down. So my dy is going to equal, I'll write it right here, du over negative 2. And now we're going to rewrite our integral so that we have those pieces plugged in. So it'll be the integral of e to the u and then du over negative 2. Now is it okay if I just put the over negative 2 in the front? Okay. Now keep your whole equation intact. What is the other side equal to? Negative 3x plus c. Remember, that side didn't require u sub. That's why it doesn't need any extra steps or anything. Yes?
So does that say u equals u to y and then
du over dy. Normally it's a du dx, but since my letter is a y, that's why it's a du dy. And then I bring my dy up, I bring my negative 2 down. Okay? So then from here, I'm going to have the integral of e to the u is what? E to the u. Very good. Okay, remember technically there's a plus c, but it's already over here on this side. And then I'm going to switch it all the way back to x's by putting my 2y back in. Okay, now remember, we want to practice getting the y by itself. So what is my next step for me to solve this? To get rid of the negative half, I'm going to times by -2. Now, technically, are you multiplying the c by -2? Yes. But since we don't know what it is, we're just going to keep calling it c. So these guys cross out. I have e to the 2y equals -2 times -3 is now a positive 6x. And then c, we still don't know what it is. So we're just going to keep calling it c. Okay, next step. How do we get rid of the e base? Yes? Oh, wait. What? Oh, you're saying my e should be a -2 up here. It is. You're correct. Sorry. And down there should be 1. Thanks. Yeah, remember, guys, sorry I wrote it wrong. Your u was a -2y. So we want to plug in -2y. Okay? So we times by -2 to get rid of the -1/2 that came in from our u sub. Next, we're going to ln. So ln and e cross out. We're almost done. We have -2y equals the ln of 6x plus c. Now, it is important that you put those parentheses so that you remember that the c is inside the log. It's not separate, okay? From there, how do I get rid of the -2 in the front? I'm going to put a -1/2 on the other side. And then ln 6x plus c. Okay, that is your general solution. Okay, then from there we have a point. It told us up here that at 0 the y value is -4. So we're going to plug in 0. Our answer should be -4. So let's see what our constant comes out to be. So -4 is the answer when I plug in 6 times 0 and then plus c. Well, what's 6 times 0? So really I have -4 equals -1/2 ln c. How do I get rid of the -1/2? Times by -2. -1/2 and -2 cross out. Well, then ln c has to equal what? -2 times -4 is 8, and then do what? E it. And then e and ln do what to each other? Cross out. C is e to the 8.
So,
Uh-huh.
we e it just to cancel it out, so to get c what c would be?
Because c was inside ln, so you had to cancel out the ln to get the c by itself. Okay, so then your particular solution would be y equals -1/2 ln 6x plus e to the 8. Okay? Alright, now the next part asks you about domain. So we covered this with square roots. The other function you have to be careful about is logs. Are you allowed to take the log of a negative number? No. What else are you not allowed to take the log of? You remember? 0. So for a square root function, can you square root 0? Yes. For logs, though, not only can it not be negative, but it also can't be 0. So when you do the domain for that, you would need to set the middle crop greater than 0. Not greater than or equal to, like you can for a square root. So it'd be 6x plus 8 e to the 8, and it has to be greater than 0. Now, you can solve that if you want to, but remember, usually you don't have to. You would just put greater than 0 and then be done. Okay? So, any type of log, you can't have an x value that is less than 0. Yes? Okay. Good?
Wait, so it can't be 0 or less than 0?
Correct. And if you think about, I'll just draw for you guys. Remember, e to the x is like this, and it never goes below the x-axis. Log is like this, and it never goes on the other side of the y-axis. So remember that those graphs are a reflection of each other. So this one never hits 0. This one never hits 0 on that axis. And remember, they have that relationship because they're inverses to each other. Okay? All right, last part for this equation, you're finding the second derivative. If this is the first derivative, What rule do you need to find the second derivative? Will it be product, quotient, or chain rule? dy dx is negative 3e to the 2y. What rule is that going to need? Product, quotient, or chain? Chain rule is correct. What is the derivative? So I'll put d squared y dx squared. What is the derivative of e to the 2y? E to the 2y times, okay, now careful, I want the derivative of 2y. Is it only a 2? 2 dy dx, very good. Remember, the reason that the dy dx has to be there is because you're taking the derivative of y with respect to x. So you have to tag a dy dx on the end. Now, I also had that negative 3 in the front, so I'm going to combine those two constants to be a what in the front? Negative 6. So I have negative 6 e to the 2y dy dx. Okay, now if you look at the second part of the question, it says to find the derivative in terms of x and y. Did we do that? Is that in terms of x and y? No. What do we need to do with dy dx? Yep, you need to replace it with actual x's and y's. You can't have a dy dx left over in your answer. So for my final answer here, I'd put d squared y dx squared equals negative 6e to the 2y times negative 3e to the 2y. Now, the second part of the question says determine where the solution is concave up. I want you to look at your second derivative. What is negative 6 times negative 3? Positive 18. And then you have an e to the 2y and an e to the 2y. Can either one of those e's be negative? No. So you have a positive 18, because the negative's crossed out, multiplied by two sets of e's that also have to be positive. Overall, what is that term always going to be? Greater than 0. No matter what number you're looking at, e's are positive, the 18 is positive, then nothing could make that negative. So you would say y is always concave up because d squared y dx squared is greater than 0 for all possible values. Okay? Now, if it asks about a specific point, you'd have to plug the point in. But since here it's kind of leaving it as an open-ended question, you'd have to be looking to see. Okay? All right, turn over to the next page, please. Sure. Okay, take a look at the next one. I want you to separate it, and then I want you to try to integrate it. Okay, and I'll come bring you a little cookie. Now, what I would say is do not find the C's, because if you mess up on your general solution, your C is going to be wrong. So on these next two, I want you to try to separate it. And actually, okay, how would you separate this? Let me just see if you get it right. Okay, so what you said isn't wrong, but it's not the easiest option. Okay, do I have to move the 6 with the W? No. Here's why you shouldn't move it. If you move it over, it's a 1 over 6. On the right side, it's like a normal 6, not a fraction. So I would only move the W on this side and the dt, and I would not move this 6. Now, it's not wrong to move this 6, but you're going to have to times to get rid of it later anyway. So I would just leave it. So in your separated form, it would be 1 over w dw. And then on the other side, you'll have 6 cosine 2t times dt. You got it. Okay, I want you to integrate and get your general solution. Look down at number 12. I'm going to have you do both. How would you separate number 12? Write it down on your paper. Okay, what would I circle and move? What term? Only the square root h. Do you have to move the 4 as well? No, and it'll be harder if you move the 4. So just leave the 4, only move the root h. So it'll be 1 over root h dh. And then on the other side, if I'm taking the root h away, I really need to distribute that 4 in here just to keep the 4 on the t side. 4t minus 8, very good. And then dt. Okay, glancing at both of those before you do your integral. Okay, I just want to make sure we're all on the same page. Will you do a u sub in number 11? Yes. Which side will you do it on? The right side. That's going to be your u. Now on the left side, what's the integral of 1 over w? ln w. Good. So you're going to end up with ln's and e crap. Okay, come down here to this one. Are you going to do u sub on number 12? No. How are you going to fix this side? Negative 1/2 as your power. So this would be h to the minus a half dh. So you should only be working u sub in number 11, not in number 12. Okay? All right, I'm going to give you a couple minutes to work. Give it a shot. I would not find your C's, because if you mess something up, then it's going to end up being wrong and it'll be more for you to fix. Yes?
So I know how to do use it, but I just don't know like where am I supposed to use it.
Here's the easiest explanation. Taking derivatives. If you would have needed chain rule, you're going to need u sub. So like for example, if I was going to take the derivative of that, would I need chain rule? 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 Yes, because of the 2t. That means that you're going to do u sub. Because u sub is kind of like doing chain rule backwards. Does that make sense?
Oh, yeah. So if you're going to do the derivative of that specific thing and you need chain rule to do so,
Yes.
then for the integral you need u sub?
Yes, exactly right. Because u sub is the chain rule, but for integration. Okay? All right, you can do it. Hello.
I do have the one.
Oh, okay, sure. Bye. Right along, your dad's here to pick you up. What day was that? Okay, I messed up that day. So this sub might have marked the wrong one. But I don't know. I have a form that I have to fill out to fix it, and I'll have you just take it down. When we finish. You can just say thanks, Queen. Oh, yes, you can. Yes? Oh, do you want it? I see you. You want one? Okay, do you want one? There you go. Okay, we know what we're doing. Okay. So what's the integral of 1 over w? That's one of your specials. So look at this one. What's the integral of... So the integral of 1 over a letter is the ln of that letter. So if it's 1 over w, it'll be ln w. Yes, you did. U sub. So your u will be the 2.
Get it like that?
Yeah. Okay, can we get our emails, please? Sean? Since I see you signed up for the AP test and you want to pass it. Yes? Huh? I didn't hear what you said. If you want.
You want to make a bet on it?
I'm not wanting to bet you'll fail. I'm just saying that you should probably pass if you would like apply. I'm saying that if you continue to piddle on your phone for the rest of the years, then yes, you're for sure. Even though you're capable and smart. Do you want the other half of it? Okay. Well, one.
I know how to do it.
Yes. You're so welcome. You didn't want one, right? You guys want a cookie?
What's inside of
What was your question, Kelly? You are? And then what's the integral of cosine? Sine. Because you're doing, remember, antiderivatives are up.
I just want to know if the other side, the ln side, plus c. That one with the plus c.
Yeah, so I would put the plus c on the cosine side. So you'd have lnw here, and then your u is 2t, so your du dt is 2, multiply the dt up, dt is du over 2, yeah? So then over here it'd be 6 cosine u du over 2. And then these guys come out as a, I'm just going to put a 3, but that's the same. Okay, so when you get to here, you have 3 cosine u. What's the antiderivative of that? Good. Okay, so instead of putting u, I'm just going to bring the 2t back plus c. Okay, then from here, did you e both sides? Yes. Okay, e and ln cross out, then you have absolute value w equals e to the 3 sine 2t plus c. Okay, I'm going to show you something in a second to make these easier. You are allowed, and I'm going to explain why in a second, to take the plus c from here and move it down to the front so that it's going to look like this. W equals ce to the 3 sine 2t. Okay, and I'm going to explain to you why right now, but from now on, if you have a plus c in addition of your exponent, then I want you to move the c down. Okay, here's how it works. You don't have to write this down, just watch on the board. Okay, if I had this right here, okay, look, watch why this is the same. Okay, I have e to this, do y'all remember this rule? A to the x plus y is a to the x times a to the y. Do y'all remember that? Yeah? Okay, so if I wanted to break this up, I would break it up into e to the 3 sine 2t times e to the c. Do you agree that that's the same? Yeah, because if it's a plus c, then I can be like, okay, you can have your own base, yeah? But then c, I didn't know what it is, right? So then is e to the c still something that I just don't know what it is? Yeah? So then I would be like, okay, well then this is the same as e to the 3 sine 2t times c. And I would just be like, okay, I don't know what c is anyway. E to the c is just another number I don't know. So then instead of writing it at the back, I would write it in the front. Okay? Now, the reason I would have you do that is that it makes finding the c a little bit easier. Okay, so rewrite your solution like this. This is why I told you not to find it. Okay, and then we'll solve it. Okay, so what is the answer when I plug in? Is it 0? Okay, what is the answer supposed to come out to be? -3. Very good. So right here I'd say -3 is the answer when I plug in 0. Okay, well, what's the sign of 0? 0. What's e to the 0? 1. So then I have -3 equals 1c, right? Well, then c is just -3. And then when I rewrite my equation, I would put it right here. So it'd be w equals -3 e to the 3 sine 2t. Now, here's the other reason that I like putting the c in the front, is that then you don't have to put a plus or minus anymore. Because think about it, if it's a c, you don't know if it's plus or minus because you don't know what it is anyway. So you get to kind of drop the plus or minus when you put the constant in the front. Okay? All right, look at number 12. What is the antiderivative of h to the minus a half? I'm going to add 1. So it'd be h to the 1/2. But then if I'm dividing by a half, what am I really multiplying by? 2. So it would be over a half, which is the same as multiplying by 2. Okay, then on the other side, I'd have 2t squared, 8t plus c. What would my next step be to solve? Divide by 2. Okay, so I have h to the 1/2. I'm going to rewrite that as square root h. And then if it was a 2t squared, now it's just a t squared. 8t is now a 4t. And then technically it's a c over 2, but we didn't know what it was anyway, so we don't really care. How do you get rid of the square root? Square both sides. The c does need to be part of your squared expression, so make sure your parentheses close it in with everything else. So h equals t squared minus 4t plus c quantity squared. Okay, do you feel confident that you could find the c on that one? Okay.
Is that the general solution?
That's the general solution. Okay, so then go ahead and find your c for me then. So your point is 1, 1. So 1 is the answer when I plug in 1. Anybody got it? 4 is correct. Good. Okay, you square root both sides to get rid of the squared around the c. Then you add your 3 across to cancel it out. C is 4. So then your particular solution would be t squared minus 4t plus 4 quantity squared. That's your particular solution. Okay. Okay, so when you square root it, you can put plus or minus 1, but if you do a minus 1 and add 3 across, you get a 2, and if you plug that in here, it ends up not working. So you could try that, but it actually ends up not mattering that there's a plus or minus because this side was already plus. Okay, yes? Sure. Okay, so will you please turn over, is that high enough, or all the way? Good? Okay, go over, you have 2 more left, and our goal is just to finish this up. So I want you to separate the next 2. You're going to have a u sub involved on both. So go ahead and separate, and then start your integration. Don't find your c's, though, because if your general solution's wrong, your particular will be wrong, too. Okay? So look at those last 2. Try to separate them first. Yeah? Sure.
This week. Maybe today, since several people have finished. Okay, so here separate. I need to have it with this switch. So your y on the bottom is going to end up way off the left side. And then your et off the bottom is going to come up to the top.
Are you going to need u sub on number 9? Yes. On which side? The y side or the t side? The t side, correct. Yes, ma'am. Okay, yeah, so if it's a plus c here, you have e to the side 2t plus c, that's the same
and 2t be together, and then I'm separating to this thing. Here's the thing about your c. Since you don't know what it is, e to the c is still an unknown, because we don't know what c is. So then you can be like, okay, well, I'm going to call all of that now c, and I'm just going to write it to the front. C is 3 sine 2t. Now, if you like this better, you can do that, but you'll have to go with plus or minus in the front, and your c will come out to be a different answer than mine. But it's not wrong. The reason I would suggest moving the c is because a lot of times it makes your c a lot less complicated when you're solving, versus if you leave it up there, your answer for this one would have come out, instead of just being a -3, it would have been e to the -3. So you'd have a totally different constant than we would have. But it's not wrong. They would both be correct. Just moving the c. Okay, taking a look at number 9, what would my separate be? Okay, y dy. And then 4 secant squared 2t dt. Okay, what's the integral of y? Power rule. 1/2 y squared. And then on the other side, you'd have to do u sub. What would you choose as your u? 2t.
Okay, 2t. That means that du is 2 dt, right? Because I'd move my dt up, which means that dt is du over 2. So far, so good? Okay, so let's plug this in. It's the integral of 4 secant squared u. dt is du over 2. What is my constant that I'm going to pull out to the front going to be? 2. So 1/2 y squared equals 2 times the integral of secant squared u du. That's a rule. What function's derivative is secant squared? Tangent. So then the integral of secant squared is tangent, because remember, they're just backwards from each other. So this would be 1/2 y squared to tan u plus c, and then I would switch it back to be a 2t. Okay, keep solving to get your y by itself. What's the next step? Times by 2, very good. 2 to eliminate the 1/2. Technically, you're timesing the c, but since we don't know what it is, we just kind of leave it as a c. So 2.5 are gone. Y squared equals, what's my number here now? 4 tan 2t plus c, and then what's my last step? Plus or minus square root. You do have to put plus or minus on the general solution, but when you find your particular solution, you'll be picking one. Now, looking at my ordered pair, I'm going to be plugging in pi over 8, and I'm going to be setting it equal to 3. Which of the signs am I going to pick for this one? The positive one. Very good.
Do you have to put like a positive that you circle?
So you don't have to write the positive as long as you don't have plus or minus. If you put nothing, that counts as a positive. Okay, so I'm selecting the positive because I needed to match my 3, which is positive. So I have 3 equals 4 tan, and then what is 2 pi over 8 the same as? Pi over 4. Okay, does anybody remember the tan of pi fourths? It's 1. Good. So really this is 4 times 1 plus c. Then how do I get rid of the square root? Square, square. What's 3 squared? 9. And then that'd be just a 4 plus c on the right side. Then I'd have to minus my 4 across c is 5. So if I'm going to come over here and slash out the 5, make sure you also slash out the negative. Okay, but I'm just going to rewrite it. So it'd be the positive square root 4 tan 2t plus 5. Why would I not get points the way I've written it?
It's not over the 5.
The 5 should have been included. Okay? All right, we probably won't have time to finish this last one, but I want to separate it. So if it's dy dx equals, y squared sine pi x, what would your separate step be? Y squared, but where would it end up when I move it? On the bottom, 1 over y squared dy. And then on the other side, I'd have my sine pi x dx. Okay, on the left side, on this y side, will your answer be ln of y squared? No, that's wrong. What do you need to do if it's 1 over y squared? Y to the negative 2. Very good. Okay, so you would bring your y squared up and you would turn it into a negative. Okay, then on the other side, I have the integral of sine pi x dx. Will that side need u sub? Yes. So your u would be pi x. That makes your du what? Pi, and then I'd move my dx up, and then my pi will move down. So it'll be dx equals du over pi. Okay? Then from here, I'd have the integral of sine u du over pi, which is really the integral of sine u du with a 1 over pi in the front. Okay, so pi is still a number just like any other number. Then what's the integral of sine? Negative 1 over pi cosine pi x plus c. Okay, let's work out the left side, and we probably just won't have time to do the constant. Okay, what's the antiderivative of y to the minus 2? Add 1 to the minus 1, but then I have to divide by negative 1, so I'm just going to put a negative 1 in the front. Okay, then that's the same as negative 1 over y. Everybody good with that? And then could I get rid of the negatives off both sides? Okay, if I multiply by negative 1 here, technically I'm multiplying the c. I'm just not going to keep track of the fact that it's negative. So now I have 1 over y, 1 over pi cosine pi x plus c. And then your last step, since there's some like this on your homework, is you'd have to flip both sides. So what is 1 over y if, oh, I'll just send it to you or something. Bye, have a good day.